In this video, we'll look how to determine permutations with like objects. The first example comes from your textbook, page 245, 2C, which is how many different ways are there to arrange the letters of Matawa? Well, the number of ways is going to be equal to how many things there are, in this case 1, 2, 3, 4, 5, 6, 7 letters, divided by any repeats. So we only have one M, that's good, but we have 3 A's. That means we must divide by 3 factorial, because each of those A's, if you switch those A's, it's still the same possibility. There are 7 factorial ways to arrange all this, but any of those A combinations, think of this as like A1, A2, A3, if you were to switch them, it's still the same possible combination. So we have to remove the times we count where just the repeated A's are switched. And same for any other repeats like the T's. There are 2 T's, so we divide by 2 factorial to account for any time T1 and T2 are switched, but it's still the same possibility. That means it's 7 factorial divided by 3 factorial divided by 2 factorial, which, if you know factorial, is just 2, and you get 420. So for this question, there are 420 arrangements. Also from the same page on your textbook, page 245, number 7, it describes Catherine's soccer team played a good season, finishing with 16 wins, 3 losses, and 1 tie. In how many orders could these results have happened? Well, let's write that down. 16 wins, 3 losses, and 1 tie. The number of ways you can organize or arrange things is just how many there are. In this case, 16 plus 3 plus 1. There are 20 things to arrange, all their games. But we have to divide by the things that repeat, and that in this case is the 16 wins and the 3 losses. So the total number of ways, we'll punch that all in our calculator at once. 20 factorial divided by 16 factorial divided by 3 factorial equals, and we get 19,380. Therefore, the question asked, how many orders could there have been? There could have been 19,380 possible orders.